Assalamu alaikum everyone. I hope you're all well. So in this video, I'll be solving difficult questions from November 2024 papers for IGCSE and O-level Ad Maths. I've done the first part of this already. You can find the link for that in the description below. The first link, you can find a number of other similar videos like this, difficult questions from recent papers in that playlist. You can find it for the 2022 papers, 23 papers, and now today I'm doing the October-November 2024 papers. Okay, so difficult questions from these papers basically. You can find a lot of other content on my channel for A-level maths later on as well. The whole syllabus is covered here. For those of you who are interested, you can subscribe, and once you're done with your Ad Maths exams, you can get a head start for that during the summer as well. All right, so let's begin with this. Let's start with our first question from this. First up, there are relatively easier questions apart from as compared to the other ones that I have later on, but these are slightly different from the other ones that you see in recent papers. I'll just have a look at. I'll just solve them quickly, and then we move on to the others after this. So there are two papers from which I've selected questions for this particular part. Paper 2.2 and paper 2.3 from November 2023 session or November 2024 session. All right, so we will be doing difficult questions from these two papers in this particular stream, inshallah. So let's begin with this. We've got this cubic graph given, and they've told us that the graph is for this particular cubic function. We need to use the graph to solve the inequality x plus 1 into x minus 1 into x minus 2 less than 1. Now, it's the same function that you have on the left side of this inequality. You want this to be less than 1. All right. Now, this function is basically y, right? So you want y to be less than 1. Now, where is y equal to 1 on this graph? You can draw this horizontal line here like this. This is where the graph is equal to 1, right? This is the line that represents y equals 1. What you can do is, you can see where is this graph below the line y equals 1. Where is the curve below this line? So what parts do you have in that region where the curve is below this line? One region is this, and the other is this. So what are the corresponding values of x that you have in this region? You can just read these values. This value here is negative 0.8. So towards the left of minus 0.8, the curve is below 1. So that's one possible set of values of x that you get from this. X should be less than minus 0.8. And then this is another region. Again, look at the graph and see where the graph is crossing this line. It's somewhere in the middle here. You can say this is 0.55. And the other value that I see here is roughly 2.25. So I can say x has to be between these two values, 0.55 and 2.25. This is another set of values of x that we've got. So it's either this or this. This is the final solution that we get from this. Walaikum assalam, Sultan. I hope you're doing well. This is the set of values of x that we get. Okay. That's the first question. So you just need to be able to solve inequalities using graph like this as well. Let's look at the next one. This is permutations and combinations. This is the next one that I want to do from this paper. Let's have a look at this. There are 3 girls and 2 boys standing in a straight line. Find the number of possible orders in each of the following cases. Number 1, no girls are next to each other. Okay, so no girls are next to each other. We can use the dashes and stars method for this, dashes and stars representation. We can use that to separate objects, right? So we could say we've got 3 girls, 2 boys. Who do we want to separate in this case? The girls need to be separated, right? Let's write that down on the side. There are 3 girls and there are 2 boys. Who is it that we do not want to separate? We do not want to separate boys, right? You start with them, you make dashes for them like this. And then who is it that you want to separate? The girls. You want the 3 girls to be separated. In the gaps between the boys, you would have the girls. You represent them with stars like this. This is one possible position. This is another possible position. This is another possible position. Now, the first case is relatively simple because in this case, the only possibility is that they're going to be alternate to each other, right? So you'll have a girl first, and then another girl, then a boy, then another girl, then a boy, then a girl. So it's going to be alternate like this. But if you use this representation, what do we get from this? This is one boy. Let's call this boy B1. Then you have another boy. In how many ways can you arrange these boys? 2 factorial ways. And then you have 3 girls. You want to place them in these 3 places. In how many ways can we do that? 3 girls, 3 places. We could just directly do 3 factorial for this. So that's 2 factorial into 3 factorial. What do we get from that? That's 2 times 6. That's 12. This is 12 possible arrangements that you get from this. Okay. What about this now? Now they have interchanged that condition. They've switched that condition. Now the condition is the 2 boys are not next to each other. Okay. So now we want to separate the boys. How do we think about this now? So again, we could say we've got 3 girls and we've got 2 boys. But in this case, we want to separate the boys. There's no condition on girls. So we start with girls and we represent girls with dashes. So we've got 3 dashes for girls, 1, 2, and 3. So the 3 girls can be placed in these 3 dashes, G1, G2, G3. And in the gaps between them, we place those boys. How many gaps do we have? 1, 2, 3, and 4. Now, in how many ways can you arrange these 3 girls? There are 3 girls, there are 3 places for them. We can arrange them in 3 factorial ways. This will just be 3 factorial. But then what about the boys? There are 2 boys and there are 4 places that we've got for them. In how many ways can you arrange those 2 boys in these 4 places? You would say that's 4p2. 4 places, 2 people to arrange, that's 4p2. Put this in your calculator, see what that gives you. 3 factorial into 4p2, and that should be your answer. Let's figure this out. 3 factorial times 4p2. And that's giving me 72. That's the final result that we get from this. Okay? Okay, there's azan going on here. I'll just have a few seconds break. 30-40 seconds, then we'll resume after that. Okay, so this is one way to do this using the dashes and stars method. Another possibility could be that you could use that total minus together method. You find the total number of arrangements, subtract from that the number of arrangements in which, in the first case, the two girls are together, and in this case, the two boys are together. So when you want to separate two objects, two people, in that case, that method also works. You just subtract from the total the number of arrangements in which those people, those objects are together, right? That will also work. You could also do that. Okay, part B. Now you've got 12 people, including these two, Angie and Bube, whatever those names are. They're divided into 3 groups of 4 people. Now those 2 specific people must not be in the same group. Find the number of ways in which the 3 groups can be selected. Okay, so now we're talking about selection, so that means that's combinations, right? The order does not matter. How can we do this? So there are going to be 3 groups of 4 people each. Okay, so we have 3 groups. We could say this is one group. 1, 2, 3, 4. Then we have another. 1, 2, 3, 4. And we have another 1, 2, 3, 4. Now, if these 2 people cannot be in the same group, what does that mean? If they cannot be in the same group, we can say this person, Angie, he or she could be in one group, and then the other one, he is another group. He's in another group. And then the third group that does not have any of them. Okay, we could have something like this. Now, in how many ways can we select the rest of the people? So we had 12 people in total. Now, if we have placed one of them in this group already, another one in this group already, how many people are we left with? We have 10 people left. So the choice is only amongst the remaining 10 people. Okay. Out of those 10 people now, we have to select 3 for this group. So we could say that's 10C3. And we have to select 3 for this group. So how many people are we left with? 7. So out of those 7 remaining people, we have to select 3 for this group. And then out of the remaining 4 people after this, we have to select all 4 for this group. You could do this in any order, it doesn't matter. You could select the last ones first. You could say 10C4 and then the previous one 6C3 and then 3C3. That will give you the same result as well. It doesn't really matter. You could do it that way as well. That will also work. Put this on a calculator and see what that gives you. Now, in this case, you don't have to divide by anything. For example, when you have 2 identical groups, when you have 2 groups of the same size, normally what we do is we divide by 2 factorial. In this case, we have 3 groups of the same size. We would have had to divide by 3 factorial in this case. However, since we are placing A here and we're placing B here, and the third one has none of them, all of these 3 groups are basically different. We know that, right? We know that all of these 3 groups are different. So that division that we used to do by 2 factorial or 3 factorial in cases like these, when you had same sized groups, we don't have to do that here. We just evaluate it as it is and see what that gives us. 10C3 times 7C3. 4C4 is just 1, so we can just ignore that as well. And that's giving me 4200. That's the result that we get from this. Okay, that's a fine answer. I hope that makes sense. Let's move on to the next one. We have this polynomial, and they're saying this polynomial is defined by this p of x equals this, where n are constants. Given that x is equal to 2 and x is equal to -1 are roots of this equation, find the values of a and b. Achha, this actually looks pretty straightforward, and I'm not sure why I selected this. Is that a difficult part of this? Okay, so this is fairly straightforward. I think I'll just skip that because all you have to do is you could input x equals 2 in this, right? That's the solution of this, and equate it to 0. That will give you one equation. Yes, now I remember why I chose that. Okay, all right. So what I'll do is I'll do it very quickly. So the first one, a into 2 cube. So this is a solution of this equation. That means it should satisfy this equation, right? If we were to input it there, the result that we get should be equal to 0, right? Let's do that. This should equal 0, and that gives us one equation, 8a minus 12 minus 6 plus b, and that becomes 8a plus b equals 18. This is one equation that we've got. Then we input x equals minus 1 and see what that gives us. X equals minus 1, that's a into minus 1 whole cube minus 3 into minus 1 whole squared minus 3 into minus 1 plus b. Let's simplify this. This gives me minus a minus 3 plus b. On the other side, we've got 0 because the result should be equal to 0 from this. Now, this gives me minus a plus b equal to 0, and the value of a turns out to be equal to b, right? That's the equation that I'm getting, a equals b. Now, we could just input that in the other equation. 18 equals 8a plus a. 9a equals 18. The value of a turns out to be 2. If a is 2, then b is also supposed to be 2 because a and b, they're equal to each other. All right, so a equals 2 and b equals 2. That's the first part. We've done that. Now for the second part. Now it says solve this equation p of x equal to 0. All right, so how do we solve this equation now? We already have the values of a and b. So that equation now is 2x cubed minus 3x squared minus 3x plus 2 equal to 0. Now we already have two factors of this equation. We already have two factors of this equation. One factor is x minus 2 from here. Another factor would be x plus 1. We've got two factors. They're given in the question already, right? So we've got x minus 2 and x plus 1 given already. These are two factors, okay? What we can do is we could find the quadratic factor from this, multiply these two, get a quadratic factor, and then either use comparing coefficients method or long division to find the remaining factor, right? So you could say 2x cubed minus 3x squared minus 3x plus 2. That should be identical to, when you multiply these two factors, you get a quadratic factor, that's x squared minus 2x plus x, that's minus x minus 2. And the other factor would be linear. You could find this linear factor either by simplifying this and comparing coefficients, or by doing long division, that you could divide this by the linear factor. Now this is possible. You could do it that way and that will work, right? You can use any of those methods and they will work. However, there's an alternative that is pretty quick. I just wanted to tell you about that using this example, and that's sum of roots formulas, sum of roots. So those two methods are pretty common. You know about them already. You could do that. It's only 2 marks. However, we could do it even more efficiently. How would that work? We've got two solutions. One is x equals 2 and the other is x equals minus 1. These are two solutions that we're given. We have to find the third solution, right? To be able to solve this equation. We already know two solutions. Now we've got something that we call sum of roots. That means whatever the three solutions of this equation are, we can find the sum of those roots using this formula. For any polynomial, we've got the same formula. It's minus b over a. A is the coefficient of the highest power term, b is the coefficient of the second highest power term. Now, what do we get from this? Minus b. A is 2, b is minus 3, right? So it becomes minus into minus 3 divided by 2. The sum of roots of this equation is 3 over 2. What that means is this is one root, which is 2. This is another root, which is minus 1. Now, whatever is the third root, you could call that something. Let's call that x. That's what you're looking for. You could find that value. You could say 1 plus x equals this, and the value of x turns out to be 1/2. That's the third solution. These solutions were already given to us, x equals 2 and x equals -1. Using the sum of roots formula, we could find that third solution pretty easily like this without having to do long division or long division or comparing coefficients. We could just do it directly like this, okay? And that will also work. That's the third solution, x equals 1/2. All right, let's move on. Now we've got to solve these two equations. Let's have a look at this now. So we've got log of x squared with base 2 plus log of x with base 16 equal to 18. Now, the bases are different. So how do we convert them to the same base? We could use the change of base rule, right? How would that work? This is log of x squared with base 2. Let's convert the other one to base 2 as well. Let's see how that might work. So we have log of x squared base 2. This we could write as log of x base 2 divided by log of 16 base 2, right? Using the change of base law. This is what we end up getting. Now let's simplify this. Log of x squared base 2 plus log of x base 2. Now these are all numbers. We could just evaluate this directly. Log of 16 base 2. What power of 2 is going to give you 16? 4, right? So this should result in 4. You can put this on your calculator as well. Just evaluate this on your calculator. Log of 16 base 2. And that will give you 4. Okay, so the denominator is 4 there, that equals 18. Multiply the whole equation by 4 to simplify everything, and that gives us 4 log of x base 2, log of x squared base 2, plus log of x base 2, that equals 18 times 4, that's 72. Okay, now how do we solve this further? This is x squared, right? We could simplify this. We could have done this previously as well as in an earlier step as well. But now, if we want to simplify this, what we can do now is we could just bring this power here, multiply it by 4 using the power law. So it becomes 8 log of x base 2 plus log of x base 2. That equals 72. These are the same terms now. 8 plus 1, that's 9. So we've got 9 log of x base 2, that equals 72. Divided on the other side, 72 divided by 9, that is 8. And now the base is 2 here. If we want to get rid of this log, we can say this base is going to go to the other side, become the base of 8, and give us x equal to 2 raised to power 8. And now this is something that we can evaluate easily. 2 raised to power 8, what's that? That's 256. You could put this on your calculator as well. And that gives you 256, and that's your final answer. Okay, that was part A. Let's look at part B now. Now we have to solve this equation. Did they give us any instruction there with respect to the final level of accuracy? No. Okay. E raised to power 2x plus 1 minus 10 into e raised to power minus 2x minus 1 equals 3. How do we solve this equation now? Now you see you've got x in the power here. X is in the power. Now to bring x down from the power, generally what we have to do is we have to use logs, right? Using the power law, then we can bring the x down. But the problem here is taking log right away is not going to help. If you were to take log on both sides here, we will have log of this and log of this. You can take any base log, it doesn't matter. The problem with that is that you have minus inside, that you would have minus inside log. And then that's something that you cannot simplify, right? When you have minus or plus on any one side of the equation like this, taking log does not help because you cannot simplify this anyway. When you have minus or plus inside log, you can't simplify that. So what do we do then? In such problems, often using substitution is what is going to help. What substitution can we use? We've got e raised to power something here, we've got e raised to power something here. Can we make these powers the same somehow? They're very similar, but not exactly the same. We can say this is e raised to power 2x plus 1 minus 10e raised to power. I could do something like this. I could take this minus common and write it as 2x plus 1 whole raised to power minus 1 like this, right? So now I've got e raised to power 2x plus 1 here and e raised to power 2x plus 1 here. Both of them are the same. And this is where we can use a substitution now. We could say let some other letter, for example, u equals e raised to power 2x plus 1, and that will make it u minus 10u raised to power minus 1, that equals 3. That's an equation that we know how to solve now. U minus 10 over u equals 3. Multiply the whole equation by u, and that will make it u squared minus 10 equal to 3u. Take everything to one side. U squared minus 3u minus 10 equal to 0. It's a quadratic equation. Can we factorize this? Yes, it becomes minus 5u plus 2u minus 10 equal to 0. We get two factors from this. One is u plus 2 and the other is u minus 5. So u either equals minus 2 or it equals 5. Put that substitution back now. You say e raised to power 2x plus 1 is either equal to minus 2 or e raised to power 2x plus 1 is equal to 5. Now the first one does not give you anything because a positive number raised to power anything can never be negative, right? You can try taking log on both sides as well, and that will give you an error, so you don't get anything useful from that. So you'll say this is not possible. There's no possible solution that you get from this. What about this? You can take log on both sides. Any base, it doesn't matter, but generally we prefer taking ln in cases where we have e like this, because that will simplify things. It becomes ln of e raised to power 2x plus 1, that equals ln of 5. And now 2x plus 1, that comes down, and it becomes 2x plus 1, put that in bracket like this, times ln of e, that equals ln of 5. Ln e is just 1. Ln e is just 1, so it becomes 2x plus 1 equals ln of 5 and x equals ln 5 minus 1 divided by 2. You can put this on your calculator now and see what it gives you. If they wanted an exact answer, you would write it like this. In this case, they haven't really specified anything like that. So you could just put this on your calculator now and write down the decimal value from that. Let's see what that turns out to be. Ln of 5 minus 1 divided by 2. And that's giving me 0.3047. In your final answer, you write down the answers to three significant figures. So that becomes 0.305. And that's your final solution. Okay, that's it. That was the final answer. Let's move on now. This is another one. Again, we've got permutations and combinations. A class of 10 students is to be selected. No, a class of 10 students includes Abby and Ben. Okay. A group of 5 students is to be selected from the class. Find the number of possible groups in the following cases. Okay, so 5 students are supposed to be selected. 5 students are supposed to be selected. If there are no restrictions, in how many ways can we do that? That's just going to be 10C5, right? We have to select 5 out of those 10 students without any restrictions. Let's see what you get from that. 10C5, that's 252, and that's our final answer. The group includes both Abby and Ben. Okay, what about this now? You had to select 5 people, right? Now they're saying these 2 people have to be there. So that means Abby is already there and Ben is also already there, right? We don't have a choice for them. It's already given that they have to be selected. All right, so now apart from these 2 people, how many people are we left with? 10 minus 2, that's 8 people. Out of those 8 people, we have to select these 3 people. In how many ways can we do that? We could say that's 8C3. Put that in your calculator and see what you get from that. 8C3, that's 56. This is going to be 56. Okay, that's the second part. Now it says the group includes either Abby or Ben, but not both. Okay. So you can only have one of them, but not both of them. Now, what are the different possible cases that you could have? One possibility could be that both of them are there. We have already calculated that case here. Another possibility could be that Abby is there and Ben is not there. Another possibility could be that Ben is there and Abby is not there. And another possibility could be that both of them are not there. Now, there could be multiple ways of doing this. One idea could be that you could find these two cases and then add them up together, and that will work. Another possibility could be that you know the total. This is the total number of combinations. You could subtract from that when both of them are selected, and also when both of them are not selected. Okay, that could be another possibility. Do it either way. Let's do it directly. We could say there are two possibilities. One possibility is Abby is there and Ben is not there. Okay, so Abby is selected, Ben is not selected. That's one possibility. Now, out of these, out of the remaining people now, there were 10 students in total, right? We have already decided about these two people. That Abby is going to be there and Ben is not going to be there. How many people are we left with? 8 people. Out of those 8 people, how many do we have to select? We have to select 4. It's not going to be 9C4, remember, because we have already decided about Ben as well in the first case that he is not going to be there. So we're not going to be selecting from Ben here. Okay? We're not going to be considering Ben when selecting from the remaining people. The other possibility is that Abby is not there and Ben is there. So that means B is there, and then again we have 4 remaining places. That's also 8C4. So you could say that's 8C4 plus 8C4, or just 2 times 8C4. Add them up together and see what you get from that. 8C4, that's 70 times 2, that's 140. And that's the result that we get from this. This is the number of ways in which one of them is selected, but not both. Okay. All right, let's move on. Now it says all 10 students are arranged in a line. So now we're talking about arrangement, that's permutation. How many arrangements are possible if there are exactly 3 students between Abby and Ben? Okay, now that's another type of question that you will see in recent papers now. There are exactly 3 students between Abby and Ben. How do you think about this? Okay, so let's represent those people using these boxes. So we've got 10 students, right? So we could say we've got 10 students to 10 boxes to represent those 10 students first of all. Okay, so we've got these 10 boxes in which we have to place those students, right? Now, there are exactly 3 students between Abby and Ben. There have to be exactly 3 students between Abby and Ben. Now, what does that mean? We have a block of 5 in which Abby is at one end, Ben is at another end, and between them we've got 3 people. Okay? So what we can do is we can merge 5 boxes. We can merge 5 boxes in this. We could say we've got this one big box that has space for 5. And inside this big box, what we do is we say, okay, we've got 5 people, Abby on one end, Ben on the other end, and between them we've got 3 other people, exactly 3 other people. In how many ways now can we arrange this? That's the question. Right? How do we think about this now? We've got 10 people in total, right? Now, these 5 people have to move together. These 5 people, they have to move together. They cannot switch these 5 boxes, they have to move together. That's the important thing. Okay, so one way to think about this could be, we could say, there are 6 big boxes outside. There are 6 big boxes. The red ones, right? In how many ways can you arrange those 6 boxes? You could say that's 6 factorial, right? But now the question is, which 3 people are going to be between Abby and Ben? We also have to decide that, right? Which 3 people are going to be in these 3 positions? How can we do that? We could say we've got 8 remaining people. We had 10 total, right? Abby and Ben are 2 of them. We've got 8 remaining people. Out of those 8 remaining people, we have to arrange 3 in these 3 boxes. In how many ways can we do that? 8p3. That's for arranging 3 out of those remaining 8 people in these 3 boxes. And then Abby and Ben, they could also switch places with each other, right? They could switch places with each other. In how many ways can they do that? 2 factorial ways. Multiply these. This is one way of thinking about this, and that should give you the result. You can see what that turns out to be. 6 factorial. Now we're not arranging the remaining letters again. We have already done that, right? So when we do 6 factorial, these 5 letters outside, their arrangements are already handled in 6 factorial, right? So we don't have to do that again. Okay, we will not be doing that again. This is going to give us the result. You can see what that is. That's 6 factorial. 6 factorial times 8p3 times 2 factorial. And that's 483 840. That's the final result that we get from this. Okay, this is one way of thinking about this. There are other ways of doing this as well, and they're equally valid. This is one way you could do it. Okay, let's move on. That was part B. This is a tricky one. You need to make sure that you understand this this logic, because this is getting repeated quite often in recent papers. Similar questions to this. Okay, now we've got a trigonometric equation that we want to solve for theta between minus 90 and plus 90. How do we do this? This is cot square 2 theta plus 3 cosecant 2 theta equals 9. Now, when we have trigonometric equations, we want to convert everything to a single type of function. Right now we've got cot here and we've got cosecant here. How do we convert them to a single function? Let's think about that. We could write cot as 1 over tan. That's one possibility. But remember what cosecant is. Cosecant is 1 over sine. So it'll be more efficient to write cot as cos over sine instead, right? That will make the denominators similar. Let me explain what I mean by that. So this becomes cos square 2 theta divided by sine square 2 theta, right? So cot is cos over sine, just like tan is sine over cos, cot is cos over sine. And now, what about this? Cosecant is 1 over sine, so it becomes 3 over sine 2 theta. On the other side, we've got 9. Okay, what do we do now? We could take LCM on the left side and see what that gives us. Cos square 2 theta plus 3 sine 2 theta divided by sine square 2 theta, that equals 9. Or you can just multiply the whole equation by sine square 2 theta in a single step. And that would give us something like this. Cos square 2 theta plus 3 sine 2 theta equals 9 sine square 2 theta. Take everything to one side. And that gives me cos square 2 theta plus 3 sine of 2 theta minus 9 sine square of 2 theta. Okay, so now the problem is we've got two functions which are sine and cos. Can we convert one to the other? We could convert sine square to cos square, but we would still have a sine here. Instead of that, it's going to be more efficient if we convert cos square to sine square, because in that case, everything would be converted to sine. So let's write cos square as 1 minus sine square. So it becomes 1 minus sine square 2 theta plus 3 sine 2 theta minus 9 sine square 2 theta, that equals 0. All right, now let's simplify this. We've got minus sine square here, minus 9 sine square here. That becomes minus 10 sine square 2 theta plus 3 sine 2 theta plus 1 equal to 0. It's a quadratic equation. You can solve it like a quadratic. We could use a substitution to simplify things. Let's just write sine as s maybe. So you could say or use any other letter, doesn't really matter. Let's say let u equals sine of 2 theta. Then this equation can be written as minus 10u squared plus 3u plus 1 equal to 0. Now it's a quadratic equation. How do we solve this? Can we factorize this? 10u squared minus 3u minus 1 equal to 0. We could use 5 and 2, right? That should work. So 10u squared plus, minus 5u, or you could say plus 2u. Minus 5u plus 2u minus 1 equal to 0, and that should work. And that gives me 5u plus 1 as one factor, and 2u minus 1 is the other factor. So the two values of u that I'm getting from this are u equals minus 1 over 5 and u equals 1 over 2. Put that substitution back. So sine square 2 theta is either equal to minus 1 over 5 or sine square 2 theta is equal to 1 over 2. Now this is not possible because a square cannot be negative. So we say this is not possible. We don't get anything useful from this. We can just cross it out or just write that this is not possible, right? A square cannot be negative. What about the other one? Sine square 2 theta is 1 over 2. Let's take square root on both sides, and that will give us sine 2 theta equals plus minus 1 over under root 2. Right? Square root of 1 is the square root of 1. Square root of 1 is just 1. And the denominator, we've got square root of 2. And now this is the equation that we want to solve. How can we solve this now? Again, you could use a substitution if you want, or just do it directly, however you've learned it. The interval that we're given is for theta. Okay, keep that in mind. Interval given is for theta. The important thing is whether you use a substitution or do it directly, you have to make sure that you adjust the interval. Interval is from minus 90 to plus 90 right now. What you do is you say, okay, that's the interval for theta. What about 2 theta? Multiply the whole inequality by 2, and that gives you minus 180 to plus 180. That's the interval that we should have for 2 theta. Okay, find the basic angle and see what that turns out to be. Sine of alpha, that equals 1 over under root 2. Find the basic angle from this. 1 over under root 2 in degrees, that should give us 45 degrees. The basic angle turns out to be 45. You can put this on your calculator, sine inverse of 1 over under root 2, and that should give you 45 degrees. Think of quadrants now. Think of quadrants. Now, sine is either positive or negative. There's no restriction, right? What does that mean? That means we could be in any one of the 4 quadrants. All the 4 quadrants are possible, right? We could be in any quadrant. That's in degrees, right? Yeah. So we could be in any one of the 4 quadrants. So what does that mean then? We have to consider all of them. We could be here, we could be here, we could be here, or here. Now the interval is from minus 180 to plus 180. So what are the possible values of 2 theta that we get from this? We get 45 degrees in the first quadrant, 135 in the second quadrant, And then we have to consider the negative side here, right? Okay, let me just confirm this. This is... Oh, okay. I put that wrong there. I'm sorry about that. So when I put that substitution back, instead of saying sine 2 theta, I wrote sine square 2 theta there by mistake. This should have been sine 2 theta, not a square there. Okay. Because that changes the basic angle for us and also some of these things. Okay, so let me go back here. So when I put this substitution back, in this case, when I put this substitution back, the substitution was u equals sine 2 theta. I wrote that as sine square 2 theta by mistake here. So I have to correct that. So this becomes sine 2 theta equals that and sine 2 theta equals this. That means this is also possible. Okay, this is also possible. So we have to consider both of them then. And in the second case, we don't have to take square root in that case. So this would actually change. There's no plus minus as well because there's no square. Okay, so this was not sine square 2 theta. It was just sine 2 theta. Okay, it was just sine 2 theta. So we've got sine 2 theta equals minus 1 over 5 or sine 2 theta equals 1 over 2. Let's find the basic angle for both of them. For the second case here, sine alpha equals 1 over 2. Sine is 1 over 2 at 30 degrees. The basic angle turns out to be 30 in this case. Okay, so now which quadrants are possible in this case? The possible quadrants are only the first and second because sine is positive. So we have to consider both of them. In the first quadrant, we get this. In the second, we get this. So we say either 2 theta is equal to 30 degrees or 2 theta is equal to, in the second quadrant, that becomes 150 degrees. So one possible value of theta that we get from this is 15 degrees. And the other possible value of theta that we get is 75 degrees. Okay, so these are two possible values of theta that we're getting. Now, what about the other equation? Sine 2 theta equals minus 1 over 5. Again, find the basic angle from this as well. Now, this is not going to be exact, so we'll have to use a calculator from that. For that, sine inverse of 1 over 5, make sure calculator is in degrees mode. You have to do this a lot. You have to keep changing your angle unit on the calculator. So make sure you are using the correct mode. So this is supposed to be in degrees. So I converted that first of all, and then sine inverse of 1 over 5. Let's see what I get from that. 11.54. That's the basic angle. 11.54 degrees. Now in this case, sine is negative. Where is sine negative? Sine is negative in the third or fourth quadrants. It could either be here or it could be here. Remember the interval for 2 theta, it's from minus 180 to plus 180. Now, in the third and fourth quadrants, if we go from the positive direction, that will go beyond 180, that will go outside the interval. So we have to go in the negative direction. We say this is the first angle that we get. So we say 2 theta is equal to minus 11.54. That's one possible angle that we're getting from this. And then in the third quadrant, what about this? That's 180 minus 11.54. That would be let's figure that out. 180 minus 11.54 in the negative direction. That's giving me minus 168.46. So what are the values of theta that we get from this? 11.54 divided by 2, and that's 5.8. Answers in degrees are written to one decimal place, so that's minus 5.8 degrees. That's one possible answer. Then the last one, that's 168.46 divided by 2, and that's 84.2 degrees. So theta is equal to minus 84.2 degrees. That's the fourth possible answer. We're getting four possible answers from this: minus 5.8, minus 84.2, 15, and 75. And that's your final answer. That's what you would write. Again, making sure that you adjust the interval is very important. If you did not do that, you would only end up getting 2 answers, and that will be wrong, of course. So you need to make sure that you do adjust that interval properly. Okay, that's it. That was this question. That was on trigonometry. Let's move on to the next one. Okay, so now they're saying a particle is moving in a straight line with constant velocity of 6 meters per second at time t equal to 0. It passes a fixed point A. At time t equals 5, it suddenly changes direction and moves with a different constant velocity along the same straight line. Okay, it passes the point A again at time t equals 15. Sketch the velocity time graph for the motion. Okay, now how do we think about this? So first of all, they're saying it's moving in a straight line with constant velocity of 6 meters per second. It's a velocity time graph. So if velocity is 6 meters per second, it's moving at that constant velocity. And then at time equals 5, it suddenly changes direction. Okay. So first of all, for the first 5 seconds, it's moving at 6 meters per second. So we have a horizontal line for that like this at 6, right? And then what happens after that? Now it changes direction. Changes direction, what does that mean? Its velocity would become negative now, right? So if it's moving in one direction and the velocity is positive, then if it changes direction, velocity becomes negative because direction of motion is determined by the sign for velocity. So now it's moving with a different constant velocity. It passes the point A again at time t equals 15. Sketch the velocity time graph for the motion. Okay, now think about this. Let's draw a rough sketch to try to understand the situation better. So this is point A, let's say. It moves in one direction. For how many seconds? 5 seconds. How much distance does it travel? It travels at a speed of 6 meters per second. It's 5 seconds. 6 into 5, that's 30 meters. You can also find the area on the graph. That's 30 meters, right? Then they're saying at time equals 15, it passes through the point A again. So now it changes direction at time equals 5. It reverses direction and it's now moving towards the left. This was t equals 5. It reaches back the point at the point A at t equals 15. It started from 0 and it's reaching back again at the same point at t equals 15. How much time is it taking from t equals 5 to t equals 15? That's 10 seconds. Now the distance traveled has to remain the same. What's the distance traveled? It should be 30 meters. So if it's coming back to the same point, the distance traveled should remain the same. That should still be 30 meters. So what's the speed going to be then? 30 meters, 10 seconds. What's the speed that you get from that? 30 divided by 10, that's 3 meters per second. So on the reverse journey, the speed is 3 meters per second. Okay? But we're talking about velocity. It's in the opposite direction. So velocity is negative. Half of 6, that's 3, but negative. We would have a horizontal line at minus 3 in this case from 5 to 15. And then we join these two parts of the graph. This is what the velocity time graph looks like for this journey. Okay, it's suddenly changing direction. It's suddenly changing direction at this point. Time equals 5. And it's moving in the other direction at a speed of 3 meters per second. That's how this velocity time graph of this journey would look like. All right, let's move on to the next part. Now it says, another particle, so now it's a different particle, is moving in a straight line with constant acceleration. So now the acceleration is constant. Remember, in a velocity time graph, acceleration is given by the gradient of the graph. Okay? Gradient of the graph represents acceleration in a velocity time graph. Okay? At time t equals 0, it passes the fixed point B with velocity minus 8 meters per second. It passes the point B again at time t equals 20. Sketch the velocity time graph for the motion. Okay, now how do we do this? So we know the starting point. It starts at minus 8 meters per second. Now they've not given us a scale for the y-axis here, so we have to use that ourselves. Now you will always do it with a pencil. Right now we don't know what scale we should take. So just to understand the situation better, I'm drawing it like this. I'm saying, let's suppose this is minus 10, then this would be minus 8, right? So the journey starts from minus 8. They're saying at time 0, the velocity is minus 8. So this is where the graph should start. Okay. It passes the point B again at time equals 20. So the graph has to go up to time equals 20. Okay, up to time equals 20. And the acceleration is constant. If acceleration is constant, that means the graph is going to be a straight line, right? The graph is going to be a straight line. And it reaches the same point again at the point B. Let's just draw a random line just to understand the situation better. Let's suppose it goes like this. Let's suppose. Now, if it is coming back to this starting point, what should happen should be this area between the graph and the x-axis and this area, they should be equal to each other. The distance that is traveled in one direction, it should be equal to the distance that's traveled in the other direction. Do they look equal at this point? They don't. The graphs have to look, the areas should be equal, because that would ensure that the particle is going back to the same point again. How do we make these two areas the same in this case? If these two areas have to be the same, the area below the line and above the line, how do we have to move this line? We can keep bringing it down. It should pass through the x-axis exactly in the middle of 0 and 20. That means at t equals 20, because that would ensure that this area and this area, they're both equal to each other. Why do they have to be equal? Because the particle is returning to the point B. If it's returning to the point B, that means whatever is the distance that is traveling in one direction, that means while the velocity is negative, it should be the same distance that it travels in the other direction. Okay? So that's the idea. Now we can draw it slightly better. So now that we know the maximum point that we have to go on the other side is just plus 8, we could take a bigger scale now. We could say, let's suppose this is minus 10, this is minus 5, this is 5, this is 10. So the journey starts at minus 8, and we know it has to pass through the point 10. And then it goes to the other side, and it would reach the other side, and the velocity would become plus 8 when time is equal to 20. That's what the velocity time graph is going to look like, because this would ensure that these two areas, they are the same, and the particle returns to the point B. All right, that's what the graph would look like. I hope that makes sense. Let's move on to the next question. Okay, the diagram shows part of this curve and the line y equals minus 4. The curve and the line, they intersect at the point A. We are given the maximum point of the curve at which is at a perpendicular distance h from the line y equals minus 4. Find the value for h. Okay, how do you find the value for h? You can find that turning point, right? How do you find the turning point? It's a quadratic function. Y equals x minus x squared over 4. That's just a quadratic function. How do you find turning points of quadratic functions? We could use differentiation. We could use minus b over 2a, completing square. Any of those methods should work. right? Let's do that. So the function is y equals, let me write it like this. It's minus x squared over 4, right? I could say that's minus 1 over 4 times x squared plus x. That's the function. Let's find the derivative for this, dy over dx, and see what that turns out to be. Minus 1 over 4 remains as it is. You multiply by the powers. So that becomes minus 2 over 4, which is 1 over 2, times x plus 1. That's the derivative. Put that equal to 0. 0 equals minus half x plus 1. And the value of x turns out to be 2 from this. Okay, so the turning point is at x equals 2. So this point has to be x equals 2. Okay, here the value for x has to be 2. What about the corresponding y coordinate at this point? Can we find the y coordinate? Let's put this back. In that original function, y equals minus 1 over 4 into 2 squared plus 2. Let's see what we get from this. Minus 1 plus 2, and that's 1. Y equals 1. So this point is supposed to be 1, right? So what's the value for h that we get then? This is minus 4 to 1. What's the height that we've got here? Height is equal to 5, right? So it's 4 units and 1 unit. That's 5 in total. The value for h that we were looking for is 5. H is equal to 5. Okay, and that's the answer that we've got. H equals 5. All right, let's move on. Find the exact x coordinate of a. Now that's relatively straightforward. We just have to find the x-intercept for that function. What's the function? The function is y equals x minus x squared over 4. Okay, so sorry, no, it's not the x-intercept. It's y equals minus 4 line. Okay, so this is not x-axis. X-axis is here. So all you have to do is put y equal to minus 4 to find this point, right? Let's do that. Y equals minus 4. Let's input y equal to minus 4 in this equation, and that gives us minus 4 equal to x minus x squared over 4. Multiply this whole equation by 4 to get rid of the fraction, and that will give us minus 16 equals 4x minus x squared. Take all terms to one side. X squared minus 4x minus 16 equal to 0. Can we factorize this? 16, no, factorization is not possible, and that's actually something that you can guess from the question statement as well. They want an exact x coordinate. That means there will be something that is in terms of square roots, right? So how do we do this? We can use quadratic formula for this. We could say x equals minus into minus b, that's minus into minus 4 plus minus square root of minus 4 whole squared minus 4 into 1 into minus 16 divided by 2 times 1. And we can see what that turns out to be. X equals, now whenever they want exact answers, we need to make sure that we show complete working. Okay, working is important. You cannot just put this on your calculator directly and write down the answer. That's not acceptable. Okay, whenever they want exact answers, you need to make sure that you show complete working. So let's simplify this. We get 4 plus minus. In the part inside, if you want, you can just evaluate that part directly from the calculator just to be sure. 16 plus 4 times 16, and that's 80. So we've got 80 inside divided by 2. Now, can we simplify this somehow? Can we write this in a simplified form? 80, we could say that's 4 times 20 or 16 times 5. 60 times 5, right? So that could be written as 4 plus minus square root of 16 times 5 divided by 2. And then we could write 4 outside. 4 plus minus 4 under root 5 divided by 2. Take 4 common from the numerator. This 2 will get divided, right? And you're going to be left with 2 plus minus 2 under root 5. These are the two possible values of x that we're getting. The question says find the exact x coordinate of A. It's a singular. That means it has to be one possible solution, not two. Let's go back. You can see this is the y-axis, right? It's on the right side of the y-axis. That means the x coordinate of a is supposed to be positive. So we only consider the positive answer from here, and we say the x coordinate of a, therefore, x coordinate of a, what is that going to be? It's going to be 2 plus 2 under root 5, and that's the solution that we've got here, 2 plus 2 under root 5, and that's the final answer. That's the x coordinate of the point A. Then it says find the acute angle between the tangent of the curve at A and the line y equals minus 4. How do we do this? Acute angle between the tangent and the line y equals minus 4. Now y equals minus 4 is a horizontal line, right? Y equals minus 4 is a horizontal line. Now that's a formula that you should remember. Its proof is also fairly straightforward, but for now, since you have an exam tomorrow, just remember this if you don't already. Angle between a line and x-axis is given by this. Tan theta equals the gradient, where theta is the angle between a line and x-axis. Now x-axis or any horizontal line, or any horizontal line, that should work, right? Because whatever is the angle with the x-axis, that will be the same with any other horizontal line as well. It will be corresponding angles, right? So this formula works for the angle between a line and any horizontal line. This is the horizontal line, y equals minus 4. Now they're saying the tangent at A, the tangent of the curve at the point A. So what would that tangent look like? It would be like this, right? So roughly like this. That's what the tangent would look like. What's the angle that this tangent is making with this line? Now for this, what we need is the gradient of the tangent. We need the gradient of the tangent. Okay, gradient of the tangent. How do you find that? Gradient of the tangent at any particular point is the same as the gradient of the curve at that point. Can we find the gradient of the curve at that point? How do you do that? Using differentiation. We've got the function. The function is y equals minus 1 over 4x squared plus x, right? That's the function. We already found the derivative before. We could just write that here again. dy over dx, what's that? That's going to be 1 over 2 times x plus 1, minus 1 over 2x plus 1, right? That was the derivative that we found earlier as well. All you have to do is put the x coordinate of the point A here. Now, in this case, there's no requirement that the angle has to be exact or anything. So all we have to do is just input that value here. What's that value? X equals 2 plus 2 under root 5. Let's see what we get from this. 2 plus 2 under root 5. The decimal value that I'm getting from this is 6.472. What's the result that we get from this? Dy over dx equals minus 1 over 2 into 6.472 plus 1. What do we get from this? Into minus 0.5 plus 1, and that's minus under root 5, or you can use decimals as well, doesn't really matter. So I'm getting minus under root 5 from this. That's the gradient of the line. That's the gradient of the tangent at that point. Okay, this is the gradient of the tangent. Okay. Now we want to find the acute angle between the tangent of the curve and that line. How can we do that? We can use tan theta equals the gradient. We can use that formula that we had there. How will that work? Tan theta equals the gradient. This is gradient. Since we want an acute angle, we can just use the positive value here. That will give us an acute answer directly. Walaikum assalam, Lubna. we could get an acute answer directly from that, or we could use the negative answer. That will give us an obtuse result, and that's okay. We could just do 180 minus that then. In order to get an acute answer, we can just use the positive value from here directly, right? So tan inverse of square root of 5, let's see what we get from that. Tan inverse of square root of 5, that's giving me 65.9 degrees, and that's the angle that we were looking for. 65.9 degrees, that's the angle between that tangent and the line y equals -4. And that's the final solution that we've got. Okay, let's move on. The last question for the session, and then we call it a day or a night. In this question, I is a unit vector in the position vector x direction, in the positive x direction. I is a unit vector in the positive x direction, and j is a unit vector in the positive y direction. Time is in seconds, and the distances are in meters. The diagram shows the initial positions and velocities of two particles A and B that move in the xy plane. Okay, so we can see their initial positions. A is starting from origin, B is starting from this point, and we have their velocities given as well. This is 5/3 in this direction, 10 meters per second in this direction. All right. Now, first of all, we're saying particle A starts from the origin at time t equals 0. It moves with constant speed 10 meters per second in the direction 60 degrees above the x-axis. We can see that here. Find the exact values of the components of the velocity of particle A in the x direction and the y direction. How do we get that? There are going to be two components, right? One in the x direction, that will be this. One in the other direction, y direction, that will be this. This is the x component, this is the y component. How do you find them? You can write them directly as well if you want. If you remember how to do that. This is 10, right? The component that's adjacent to the angle, that's the x component in this case, that will just have cos with it. So that's 10 cos 60. And the component that has that is on the other side of the angle, that's going to have sine with it. So it becomes 10 sine 60. Cos 60 is 1/2, right? So 10 into 1/2, that will give us 5. And the y component, that's 10 into under root 3/2, and that gives us 5/3. This is the y component that we've got from this, right? The logic behind this is that right angle triangle, you can just use sine and cos ratios, right? So x over 10, this side is 10, right? X over 10 is equal to cos of 60, and y over 10 is sine of 60. That gives us x equal to 10 cos 60 and y equals 10 sine 60. All right, so these are the values of x and y that we're getting. Now, that was the first part. That's all that we had to do here. Now it says find in terms of t the position vector of particle A at time t. Okay, how do we do this now? What's the initial position? Initial position is origin, so it's starting from the origin. What happens at time t? What happens at time t? Now they're saying I is the unit vector in the positive x direction, j is the unit vector in the positive y direction. How do we write the position vector of the particle A at time t in this case? It's starting from the origin, right? So generally what we do is we use the starting vector here, and then we add to that the velocity vector, right? In this case, that's a 0, 0, so you can just skip that as well. Then t times the two components. What are the two components? The x component is 5 here in this case. The y component is 5/3. What does that become? That becomes 5t and 5/3 times t. These are the two. This is the vector. The position vector of particle A at time t. You could write it like this, or you could say this is 5ti plus 5/3 tj, right? Both of them are going to be okay. This is what you end up getting from this, all right? Then it says, particle B starts from the point 2/√39. So that's the starting point for particle B. it moves with constant speed 5/3 parallel to the positive x-axis. So only the x coordinate is changing, the y coordinate is not changing. Find in terms of t the position vector of particle b at time t. What do we do about this now? The starting position is 2 under root 3 and 9, right? That's the position vector initially. Then what happens every single second? The x component changes at this rate, 5/3. And what about the y component? There's no change in y, right? It's just moving in the horizontal direction. There's no vertical change as such. So that's a 0. Simplify this and see what that gives you. You get 2 under root 3 plus 5/3 times t and 9. That's the position vector that you get for the particle b in this case. All right, and that's your final answer. What about the next part now? It says, hence show that the particles collide. Okay, how do we show that the particles collide? If the particles collide, their position vector at some point will become equal to each other, right? Their position vector at some point will become equal to each other. Now, what are the position vectors that we've got? We found the position vector for both of them. For the first one, it was 5t. Let me write that down here. 5t and 5 under root 3t. That's the position vector of the particle A, the first particle. And the other particle, its position vector is 2 under root 3 plus 5/3 times t and 9. Now, if the particles collide, this equation should give you a solution, right? There should be some value of t at which the two vectors become equal to each other. Now, we're getting two equations from this, right? This is one equation, this is another equation. 5t equals 2 under root 3 plus 5/3t. That's one equation that we're getting. 5 under root 3t equals 9. This is the other equation that we're getting. Okay, now let's find the values of t that we get from this. From the first equation, we get 5 minus 5/3. What's that? 5 minus 5/3, 10/3. So that's 10/3 times t, that equals 2 under root 3. The value of t that we're getting from this is this 2 under root 3. No, sorry. 2 under root 3. Oh no, what am I doing? I have shift pressed there. 2 under root 3 divided by that. And that's giving me 3 under root 3/5. This is one value of t that I'm getting. What about the other one? Let's see what we get from that. 9 divided by 5 under root 3. That's the same thing. That's 3 under root 3/5. Since we are getting the same values of t from both of them, that means they collide. They will collide at this particular value for t when t is equal to 3 under root 3/5. Okay, this is the time instant at which they are going to collide with each other. Okay, 3 under root 3/5. So we say, since both of these are the same, the particles A and B, they collide at t equals 3 under root 3/5. This is the time instant at which the two particles collide with each other. If we were getting two different values of t from this, so sometimes they will ask you to show that the particles do not collide. You will equate these position vectors. The values of t would not turn out to be the same, and that would mean that the particles do not collide. Okay, in this case, they're turning out to be the same. So that means that they do collide. Okay, that's it. These were all the difficult questions from the October-November 2024 papers, the relatively more difficult ones. I hope that was helpful. I wish you all the best for your exam tomorrow, inshallah. You can find other similar videos in the playlist in the description below as well. The first link that you see there, and some revision videos as well. They're primarily made for A-levels, but I've made a separate playlist for you for admins, for the topics that are relevant for you guys. and a lot of people find them extremely helpful before their exams. You can have a look at those revision videos in the description below as well. That's it for today. I will see you again later on in your A-levels. This channel is primarily for A-levels until now. I'm trying to add more content for O-levels and IGCSE from the coming year as well, inshallah. But you will find this extremely helpful for your A-level preparation. You'll find the whole syllabus covered, a lot of topical past papers, yearly past papers, difficult questions videos just like this for all the 4 papers that you will be giving in paper 3, giving in A-levels. You can have a look at that content during the summer break, and subscribe to the channel if you haven't already done that. Share with others if you found this helpful, and I'll see you again at another time after your exams, inshallah, when you start your A-level maths. And I wish you all the best for your Ad Maths exam right now. All the best. Allah Hafiz.